Balaur bondoc. Balaur bondoc is a species of theropod dinosaur from the late Cretaceous period, in what is now Romania. It is the type species of the monotypic genus Balaur, after the Balaur, Romanian pronunciation, a dragon of Romanian folklore. The specific name bondoc, Romanian pronunciation, means stocky, so Balaur bondoc means stocky dragon in Romanian. This name refers to the greater musculature that Balaur had compared to its relatives. The genus, which was first described by scientists in August 2010, is known from two partial skeletons, including the type specimen. Fossils of Balaur were found in the Danțas Shula and Subs formations part of Cretaceous Romania called Hoțag Island. Hoțag Island is commonly referred to as the island of the dwarf dinosaurs, and was part of the European archipelago of the Tethys Sea approximately 70 million years ago, when world sea levels were higher and much of Europe was tropical or subtropical. Early studies of the fossils placed the animal among the group of dromaeosaurid dinosaurs that includes Velociraptor, which was similar in size. Subsequent phylogenetic analyses have since placed Balaur among Basilavialians, the group that includes modern birds. Unlike other early Paravians, Balaur had not just one but two large, retractable, sickle-shaped claws on each foot, and its limbs were proportionally shorter and heavier than those of its relatives. As with other dinosaurs from Hoțag, such as Magyarsaurus, a dwarf sauropod, its strange features have been argued to show the effects of its island habitat on its evolution. Description: Balaur is a genus of theropod dinosaurs estimated to have lived about 70 million years ago in the late Cretaceous, Maastrichtian, and contains the single species B. bondoc. The bones of this species were shorter and heavier than those of basal Paravians. While the feet of most early Paravians bore a single, large sickle claw on the second toe which was held retracted off the ground, Balaur had large retractable sickle claws on both the first and second toes of each foot. In addition to its strange feet, the type specimen of Balaur is unique for its status of being the most complete theropod fossil from the late Cretaceous of Europe. It also possesses a great number of additional autapomorphies, including a reduced and presumably non-functional third finger, consisting of only one rudimentary phalanx. The partial skeleton was collected from the red floodplain mudstone of the Subs formation of Romania. It consists of a variety of vertebrae, as well as much of pectoral and pelvic girdles, and a large part of the limbs. It is the first reasonably complete and well-preserved theropod from the late Cretaceous of Europe. It is similar in size to Velociraptor, with Balaur's recovered skeletal elements suggesting an overall length of around 1.8 to 2.1 meters, 5.9 to 6.9 feet. Balaur had re-evolved a functional first toe used to support its weight, which bore a large claw that could be hyperextended. It had short and stocky feet and legs, and large muscle attachment areas on the pelvis which indicate that it was adapted for strength rather than speed. Cheeky et al. described this novel body plan as a dramatic example of aberrant morphology developed in island-dwelling taxa. The stocky feet are exemplified by the length of the metatarsus being only 2 times its width. It is 1.5 times wider than the lower leg. Both traits are unique in the theropoda. The skeleton of Balaur also shows extensive fusion of limb bones. Wrist bones and the metacarpals are fused into a carpometacarpus. The pelvic bones are fused. The shin bone, calf bone and the upper ankle bones have been fused into a tibiotarsus and the lower ankle bones and the metatarsals into a tarsum-to-tarsus. The degree of fusion is typical for the aviali, the evolutionary branch of the birds and their direct relatives. Discovery and naming. The first small bones belonging to Balaur bondoc consisted of 6 elements of the front limbs. Named specimens Fkabar. 1580 to 1585, these were discovered in 1997 in Romania by Dan Gregorescu, but the morphology of the arm was so unusual that scientists could not correctly combine them, mistaking them for the remains of an oviraptorosaur. The first partial skeleton was discovered in September 2009 in Romania, approximately 2.5 kilometers north of Subs, along the Subs River in the Subs formation dating from the early Maastrichtian, and was given the preliminary field number SBG/ASK1. Later it received the holotype inventory number MVP.313. The discovery was made by the geologist and paleontologist Matjaž Vermeer of the Transylvanian Museum Society of Cluj-Napoca, who sent them for analysis to Zoltan Chiki of the University of Bucharest. The findings were described on August 31, 2010, in the Proceedings of the National Academy of Sciences. The 1997 specimens indicate an individual about 45% longer than the holotype. They were also found in a younger stratum. The generic name Balaur, 3 syllables, stressed on the second /a/, is from the Romanian word for a dragon of Romanian folklore, while the specific epithet bondoc, pronounced like bondoc, meaning a squat, chubby individual, refers to the small, robust shape of the animal. As the Balaur is a winged dragon, the name additionally hints at the close relation of Balaur to the birds within pinafs. Bondoc was chosen by the discoverers also because it is derived from the Turkish bunduk, small ball, thus alluding to the probable Asian origin of the ancestors of Balaur. Classification. The position of Balaur relative to other bird-like dinosaurs and early birds has been difficult to determine. The initial phylogenetic analysis placed Balaur bondoc closest to the Asiatic mainland dromaeosaurid species Velociraptor mongoliensis. A 2013 study by Brusate and colleagues, using a modified version of the same data, found it in an unresolved close relationship with the dromaeosaurids Deinonychus and Allosaurus, with some possible alternative trees suggesting it branched off before the common ancestor of Deinonychus and Velociraptor, while others maintained it as the closest relative of Velociraptor, with Allosaurus as their next closest relative. More recent analyses using different sets of anatomical data have since cast doubt on a dromaeosaurid classification for Balaur. In 2013, a larger analysis containing a wide variety of coelurosaurs found that Balaur was not a dromaeosaurid at all, but a basilavialan, more closely related to modern birds than to Ornithiforms but more basal than omnivoropterygiforms. A study published in 2014 found Balaur to be sister to Pygostylea. An independent analysis using an expanded version of the original dataset, the one that found Balaur to be a dromaeosaurid, drew a similar conclusion in 2014. In 2015, researchers Andrea Cow, Tom Bruham, and Darren Neisch published a study which specifically attempted to clarify which theropods were close relatives of Balaur. While their analysis could not completely rule out the possibility that B. bondoc was a dromaeosaurid, they concluded that this result was less likely than the classification of Balaur as a non-Pygostylian avialan based on several important bird-like features. Many of the presumed unique traits would in fact have been normal for a member of the avialae. Typical bird features included the degree of fusion of the limb bones, the functional first toe, the first toe claw not being smaller than the second claw, a long penultimate phalanx of the third toe, a small fourth toe claw and a long fifth metatarsal. Paleobiology. Diet and lifestyle. Little is known about the behavior of Balaur. Because of the lack of skull material, it is impossible to determine by the shape of the teeth whether Balaur was a carnivore or a herbivore. The original description assumed it was carnivorous because it had been found that it was closely related to Velociraptor. Cheeky speculated in 2010 that it may have been one of the apex predators in its limited island ecosystem, as neither the skeletons nor teeth of larger theropods have been discovered in Romania. He also believed that it likely used its double sickle claws for slashing prey, and that the atrophied state of its hands indicates that it probably did not use them to hunt. One of the original discoverers indicated that it was probably more of a kickboxer than a sprinter compared to Velociraptor, and was probably able to hunt larger animals than itself. However, more recent studies by Denver Fowler and others have shown that the foot anatomy of Baravians like Balaur indicate that they use their large claws to grip and pin prey to the ground while flapping with their proto-wings to stay on top of their victim. Once it was worn out, they might have proceeded to feast while it was still alive, as some modern birds of prey still do. Due to the shape of the claws, they would not have been effective in slashing attacks. The very short, fused metatarsus of Balaur and enlarged first claw, strange even by true dromaeosaur standards, are thought to be consistent with these newer studies, lending further support to the idea that Balaur was a predator. Italian paleontologist Andrea Cow has speculated that the aberrant features present in Balaur may have been a result of this theropod being omnivorous or herbivorous rather than carnivorous like most non-avian theropods. The lack of the third finger may be a sign of reduced predatory behavior, and the robust first toe could be interpreted as a weight-supporting adaptation rather than a weapon. These characteristics are consistent with the relatively short, stocky limbs and wide, swept-back pubis, which may indicate enlarged intestines for digesting vegetation as well as reduced speed. Cow referred to this as the Dotoraptor model. However, in light of the research done by Fowler et al., Cow has remarked that the anatomy of Balaur may be more congruent with the hypothesis that Balaur was predatory after all. In 2015, Cow et al. Reconsidered the ecology of Balaur again in their re-evaluation of its phylogenetic position, arguing that if Balaur was an avialan, it would be phylogenetically bracketed by taxa known to have been herbivorous, such as Sapiornis and Johornis. This suggests a non-hypercarnivorous lifestyle to be a more parsimonious conclusion and supports Cow's initial interpretations of its specializations. This is also indicated by the reduced third finger, the lack of a gynglymoid lower articulation of the second metatarsal and the rather small and moderately recurved second toe claw. Balaur had a broad pelvis, a broad foot, a large first toe, and broad lower ends of the metatarsals relative to the articulation surfaces. Such a combination can in the remainder of the theropod only be found with the herbivorous Therizinosauridae. Island effects. During the Maastrichtian Age, much of Europe was fragmented into islands, and a number of the bizarre features of Balaur are thought to be a result of an island effect, the relatively isolated conditions imposed on many of the populations in this area. Species which are isolated on islands can be subject to the effects of genetic drift and the founder effect, which can magnify the effect of mutations which might be diluted in a larger population. Other island effects such as Foster's rule, which describes how small mainland species become larger and large mainland species become smaller, can take effect. Cretaceous Romania is known, for example, for its dwarf sauropods. In 2010, this island effect was assumed to consist in rapid changes in a relatively recently arrived invading species and not seen as the result of an isolated development of an endemic form during tens of millions of years. The assumed close relationship to Velociraptor would have implied that the isolation of Hotzig Island must have been relative and intermittent. In 2010, the increased robustness of Balaur was compared to parallel changes seen in isolated herbivorous mammals. In 2013, it was claimed that Balaur was the only vertebrate predatory island species known to have become more robust, and it was suggested that its broad feet had evolved to improve stability. The 2015 interpretation of Balaur as an omnivorous member of the Aviale suggested it was the descendant of a flying species that had developed a larger size similar to the development in several other island herbivores. This would then be a rare instance of secondary flightlessness in a Paravian looking like a dromaeosaurid, as predicted by Gregory S. Paul.